Assalamu alaikum. In this problem, we are given two integers n and k. So here the first one is n and the second one is k. Here n equals 7 and k equals 2. So here we will consider numbers from 1 to n. 1, 2, 3, 4, 5, 6, 7. Okay. So there are 7 numbers. We'll divide it into two portions. So for each portion there will be 3 numbers. Okay, in the first portion there will be 1, 2, 3. Okay, in the second portion there will be 5, 6, 7. Okay, and the remaining number will be 4, the middle one. Okay, and this number will contribute to the answer. The current answer is 4. Again, we will divide this segment into two portions. The number is 3, so 3 divided by 2 equals 1. Each segment will have only one number. The first segment will have 1, second segment will have 3, and 2 will contribute to the answer. Again, here first segment will be 5, second segment will have only 7. Okay, two segments, and the remaining number will be the middle one, 6. It will contribute to the answer. So the answer will be, okay, again we need to consider k. Okay, here k equals 2. What does it mean? It means we cannot uh, divide any portion further while its length is less than k. Here this length is less than 2, and this length is less than 2, so we cannot divide it further. So here the answer will be 12. Here it is 12. Okay, if we consider this test case, then n equals 11, k equals 3. Now we are considering numbers from 1 till 11. Okay, first we will divide it into 2. Here 1 till 5, here 7 to 11, and the middle element is 6. It will contribute to the answer. So the answer is currently 6. Okay, now again here will be two numbers, here will be two numbers, and the middle number is 3. It will contribute to the answer. Again here 7, 8, 10, 11, and the middle element is 9, which will contribute to the answer. Now if we look on the value of k, it is 3, and now the current length of each partition is 2, so we cannot proceed further, and this is our final answer. It is 9 plus 9 means 18. Here the answer is 18. Okay, now how can we solve this? Okay, we may first think that we can recursively solve it. Recursively means we will divide it into two portions, again divide it into two portions, divide it into two portions, and so on. Okay, but if we proceed like this, okay, then the complexity will be order of n, because at last, if k is very low, then at last we will see that every element is a single portion, like this. Okay, so the complexity will be order of n, but the value of n is very high, so we cannot make a complexity n here, and it will get daily. So how can we solve it? Okay, if we again consider this portion Elvin's tree, we'll get an idea. Okay, before that, uh, let's say we have this portion, we are dividing it into two portions. Here the length of these two portions are equal. Again, if I divide this into two, here the length of all the portions are same. Here the length of all the portions are same. So if the length of this portion equals this portion, and everything is similar, then it is enough to calculate everything for this portion only, and then maybe mathematically calculate something for this. This is easier, because this requires only log n complexity. Why log n? Because we are every time dividing it by 2. Okay, now coming back to this, here the two portions will be, it will be 1 to 5. Okay, it will be 7 to 11, and the middle portion will be 6. Okay, now it will contribute to the answer 6 plus. Now again, while we divide this portion, we will get 1 2, we will get 4 5, and the middle will be 3. Okay, for this, here 7 8, it is a portion. Here 10 11, and the middle element is 9. Okay, can we see a similarity? Here 1 2 3 is taken, 4 5. Again here 7 8 9 is taken, 10 11. But if I add maybe 6 with every element, then what it becomes? It becomes like exactly like the first portion, 2 3 4 5. Okay, now what we are taking? We are taking this element to the answer. Okay, now if the count of this element is comes multiple times, then what we should do? We should calculate the value for this portion, and we will assume that this portion will also have the same type of count or same type of sum. Okay, but here the sum will increase with 6 every time we count a new element, like this. Okay, so we can like apply this concept. We will calculate only for the left portion, and we will then mathematically calculate the right portion, the answer for the right portion. Okay, if we see the code, first of all the test case is taken, then the value of n and k are taken. Okay, uh, call this function calculates the sum. Okay, this calculates the sum and the count means how many elements we have taken that contributes to the sum. Okay, so as we only want the sum to be printed, that is why we have uh, expressed it like this: call n dot first. That means we want to print the first element. Okay, now we are passing the value of n. Why? Let's say I have these two elements and k equals 3. Then I do not need to proceed with this. So if n is less than k, here n equals 2. Okay, when like n equals 8, then we will consider values ranging from 1 to 8. So in this case, while n is less than k, we will return 0, 0. The sum is 0 and count is 0, because we are not proceeding to the next step anymore. Okay, again, if I have this segment, what I am doing is I am dividing it into two segments. Okay, and I want to calculate the sum of this segment, and with the help of this segment I will automatically calculate this one. So I will only recursively call this one, and from this one I want to calculate this portion. Okay, so I need to recursively call this portion. Here I am calling it. If the length here is n, here the length will be n by 2. So call n by 2. Okay, again the first one will be sum and the second one will be count. Why we are keeping this count? Because while calculating sum we need this count. Okay, if n is odd, then what happens? Like if here n equals 7, then we will take 1 till 3 and 5 to 7, and the value 4, this 4 will get contributed to the answer. Okay, now what will be the sum? The sum means the answer, actually the final answer. I have expressed it as sum, so it will take this value, this 4. And what is 4? 4 is nothing but 7 plus 1 by 2. Like here 4 is m equals 4 in this case. Okay, so I will contribute, so this 4 will contribute to the answer. Here sum equals m. Okay, this m. Okay, again I will get a sum for this portion. Whatever the sum is in this portion will have this sum also, but this portion will have some additional sum. Like uh, I have taken 1 2 3 in previous example. What we have seen, 1 2 3 4 5, like we have taken this. Again we got this type of value in the right side. This is the left portion, this is the right portion. Actually the right portion is like 7 8 9 10 11, but for simplicity and for calculating it with the help of left portion, I have written it like this. Here the additional plus 6 is used, but the sum here is 3, here is also 3, so we can write it like 2 into 3. Okay, but with some additional value plus 6. Okay, if there were like again another value taken, then this 6 will contribute to two numbers, like 6 into 2. Okay, exactly this is done here. The child sum is multiplied by 2 because it has been contributed into two parts, but the right part has some additional value. Which is the additional value? The number of count in child part. Here, like we have seen that here are 2. Okay, this additional part here is the, okay, again if I say, unfortunately it got erased, so here the exact sum will get contributed to here also, but with some addition. What is the addition? The addition is middle element, like what we have seen previously plus 6. It was middle element there. Okay, and how many times it will get contributed? The number of taken elements, so child count. Okay, so this is the case of sum. Okay, now the case of count. Count means the number of elements that is has been contributed to the answer. So if n equals 7, as we are assuming that n is odd here, okay, so it will be 1 2 3, and it will be 5 6 7. Now again there these two will get contributed to the answer. This 6 will get contributed to the answer in the later part. Okay, so there will be in this part there will be count only 1. In this part there will be count only 1, but again as we are taking this 4, so what will happen? Let's say there is count x, there is count x, and again we are taking 1 from here, so it will become 2x plus 1. That means 2 into count of its child, count in its child. Okay, so exactly this is done here, 2 into child count plus 1, and lastly we are returning this. Okay, now this is for odd. After returning, only the even part remains. So for even part, this is a bit simpler. We will make it into two equal segments. Okay, now what will be the sum? Let's say it is child sum. Again, it will also be child sum. Okay, so child sum into 2. Again, this part will have some extra value contributed, which we have explained in the word portion. We will get this. This is the sum. Again, for count, this the count of this part and the count of this part are same. So if we get the count of this part, we can multiply it with 2, and as it is not odd, it is even, so we will not get anything in the middle. So there is no plus 1, so only child count into 2, and lastly we will return this sum and count pair. Okay, thank you.